In lesson 8.1, similar shapes and scale drawings, we're going to work on the primary standard is 7.G.1, which I already talked about in the background information. It's also related to the ratios and proportions standards, and we're also going to look at the 7.RP.2b and 7.RP.1. So how can you use scale drawings to solve problems? So in the engineering world, we use blueprints quite a bit. So a blueprint is a technical drawing that displays architectural plans. And the reason why it's called a blueprint, because if you take a look here, it's blue and it's a print. Okay, so we're looking here is a blueprint's a technical drawing that usually displays architectural plans. Pete's blueprint shows a layout of a house. Every 4 inches in the blueprint represents 3 feet of the actual house. One of the walls in the blueprint is 24 inches. What is the actual length of the wall? So right here, this is the wall that we're talking about, 24 inches. And what they're showing us down here, and this is called a rate table, is that as it tells us up here, for every 4 inches, here's the units, that represents 3 feet. So if I go 4 inches, I go 3 feet. If I go another 4 inches, which would be 8, I will be at 6 feet. If I go to 12 feet, so that's another 4, so plus 4, plus 4. So this would be plus 3, so that would be 9. So go ahead and finish figuring these out. What would the actual length be at 16 inches, 20 inches, and 24 inches? So you should have come up with 12, 15, and 18. So a couple things I want to point out before we go on. Again, like I said, this is called a rate table. It helps you visualize and set up your information to organize it so that you can make decisions. The second thing is that 4/3 is called a ratio. So if you remember when we talked back in ratios and proportions, a ratio is some number over another number. So here's an example, 1/2, or we can write it as a 3, and we say it as 3/4, okay, but it's 3:4. But to expand on that, if we take a look here and we recall a unit rate is something per 1. Remember our line, we said per, and whatever the 1 unit is. So this example here is 4 meters per 1 hour. So a person is walking 4 meters every hour. That comes from rate, which is something over something. So the example we can have as 8 meters per 2 hours, or the person is walking 8 meters every 2 hours. What this does is this helps relate, these two are related to each other through what we call a proportional relationship. Because if we take a look here, what we did was that we took 8 divided by 2 is the same as saying 4/1. Okay, so that's a proportional relationship where the ratio of one is equal to the ratio of the other. So if I took 1 divided by 2, that's going to be 0.5. If I take 2 divided by 4, that also is going to be 0.5. And if I did 3 divided by 6, that's going to be 0.5. So from a decimal standpoint, they're all the same. So we have a ratio here of 4/3, and if you did the division to turn that into a unit rate, 4 divided by 3, it would be 1.33 with a repeating. If you do 8 divided by 6, it too would be 1.33 repeating. And 12 divided by 9, 1.33 repeating. All of these, if you do the decimal and find the unit rate, would be 1.33 repeating. These are proportional relationships. So I went ahead and extended the rate table. 24, 48, I added 4. 32, I added another 4. 36, I added another 4. So obviously the 36 is greater than the 33, but the 32 is less. So we're going to have to do a couple things here to figure this out. So you'll need to figure out what this value is going to be, and this one, and this one. And I've given you enough information here to do that. So from the filled in rate table, we can look at this. The back wall of the house is 33 feet long. What's the length of the back wall in the blueprint? Meaning what's it in inches? Well, certainly we don't see 33 feet in here, so we kind of have to ask ourselves, what can we do? I know that if I take the 15 feet is 20 inches and I double that, that gets me pretty close. So I have 20 over 15 plus 20 over 15, so that gives me 40 feet, or 40 inches, because this is inches to feet. And I'm going to talk more about this in a moment. And then, of course, that's 30. But I'm still short. If I go back, I know that if I need 3 more feet plus 4 feet, or 4 inches, and 3 feet, that's going to be 44 inches to 33 feet. So then that is what my answer would be. We are doing proportional relationship. We are not doing fractions. Because with fractions, we would not be adding this, okay? That's why I'm allowed to add these numbers that are in the bottom. They're not called denominators, okay? But they're numbers that are in the bottom. It's 20 inches to 15 feet. So another way that we can work with this, besides the rate table, which is just an organizational tool to help you out, is that we can find the unit rate. So they gave us 4 inches is equivalent to 3 feet. So one of the techniques I do is I always write my units on the outside. I call it on the outside. But inches to feet. Because that way I know where I'm going to keep whatever it is I'm working with at what side. So this is going to be 4 inches to 3 feet. Now to find that unit rate, you remember we do the division. We do 4 divided by 3. Okay? So 4 divided by 3 is equal to 1.33 repeating. But the other thing we have to do is we have to do the 3 divided by 3 also, and that is equal to 1. But these are proportional to each other. They are a proportional relationship. 4 over 3 is equivalent or equal to 1.33 over 1, and that's in inches, okay? And that's in 1 foot. So this becomes a very useful tool when you're trying to figure out anything. And again, it goes to setup. So if I have my inches over feet and I know that I have 1.33 inches for every foot, then I can go ahead and find any unknown if I'm given a value. So they gave us a value of 33 feet in question 2. Notice I put it on the bottom. So I can ask myself, 1 times what number will give me 33 feet? Well, obviously it's 33. So what I do on the bottom, I'm going to do on the top. So I'm going to take 1.33 times 33, and if you do the math, and I can do that for anything else that I wanted to do also. So another example, 1.33 repeating over 1 is equivalent to, if I have, let's say, 6 feet. So obviously 1 times 6 is equal to 6. So what I do on the bottom, I do on the top, and that equals 8. So for every 8 inches, my scale drawing will give me 6 feet. So going on to using a scale drawing to find an area, we're going to look here at the scale drawing is a proportional two-dimensional drawing that is similar to an actual object. It can be used to represent an object that's smaller or larger than the actual object. And a scale is a ratio between 2 sets of measurements. So if we take a look down here, they give us this actual mural that's going to be painted. And it's going to be 28 inches long, 11 inches high. And here's the scale. What they're saying is, for every 2 inches, there'll be 3 feet. But down here, what they want to do is they want to find the number of feet represented by 1 inch in the drawing. So they're talking about this one here. Now don't confuse this with the unit rate, because we have the 1 is on top. What they're showing you is they're going to take the 2 inches divided by 2, because they want to know for every 1 inch, how much is that equivalent is in feet. So they're taking 3 feet divided by 2, and that's going to be 1.5. So what I've done here is I'm going to create a rate table just to organize some of the numbers for us, and then I'm going to show you how you can find your numbers directly. So again, I put my inches on top, my feet on the bottom. They've already shown us how to find that 1 inch is equal to 1.5 feet. So now I'm going to go, is 2 inches is equal to 3, which is what the original information. And then 3 inches is equal to 4.5. And then 4 inches is equal to 6. Now I want to make a big jump. And this is going to happen to you on the in the book and on your quizzes and tests. I want to go to, say, 9 inches. So what is 9 inches? Well, what I did was I took 1 times 9 to get this. So I'm going to do 1 times 9 to get this answer here. My answer is going to be 13.5 inches. So learning how to set this up and doing this is very helpful. So now what if I say I have 13 inches? What would that be? So if I took 1 times 13, okay, to get there, so 1 times 13, get that answer. So 1.5 times 13 is equal to 19.5 feet. So knowing how to do this is very helpful. Now, we set up a rate table, and you can kind of go up like that. But what if we went ahead and just did this way using a scale factor instead? So I know that my inches are 1 inches to 1.5 feet. Okay. So now in the book, in the example, I want to find 28 inches. Notice that I write it up top there. So multiply that by 28. This is my x because I don't know what it is. So if I take 1.5 times 28, that's going to equal, times 28, that's going to equal 42. And then I also have to do for the width, which is 11. So I got my inches over feet equals 1 over 1.5. I just keep it out again. I keep this off to the side so it doesn't clutter up my numbers. So that's going to be 11 inches here, and that's x. So I multiply this by 11, so I multiply that by 11, and I will find this is going to be 16.5 feet. Okay, there's my units. So when you do it this way, you don't have to rewrite your units. It's already given to you until you actually write them out. So what they wanted, though, is what is the area of the actual wall. So area is equal to length times width. Now I have two variables here. When they're next to each other, that means you're going to multiply. So if I wrote it out, it would be length times width. But in algebra, we're not going to be doing that anymore. We're just going to head and have those two numbers next to each other, and you're going to have to know that that means to multiply. So I'm going to go ahead and take what they show you right here, 16.5 times 42 feet, and the area of the actual wall is going to be 693 square feet. So here in the Your Turn, they talk about the drawing plan for an art studio shows a rectangle that is 13.2 inches by 6 inches. The scale in the plan is 3 inches per every 5 feet. Find the length and width of the actual studio. Then find the area of the actual studio. So a couple of things that we're going to do. Remember I talked to you about setting up inches over feet in this case, all right? And that's going to be equal to 3 over 5. Okay, that's this piece right here. And then I'm going to go to 13.2 inches. Now this is a little bit different, and I'm going to show you on the next slide here. What we're doing is that instead of finding that unit rate, we can go right from here to find out what this is. Now, it's not very clear cut for you to do that. How do you go from 3 to 13.2? Well, if you remember, I have been showing you to do some number, okay? Well, let's remember inverse operation. What is the opposite of multiplication to get here? It's division. So what I do then is I take 13.2 divided by 3. That's going to equals 4.4. Now what I can do is I can go ahead and multiply this by 4.4, and that's going to equal 22. So if you do your drawing, and that's the other thing I recommend, it says that the drawing plan for an art studio shows a rectangle as 13.2 by 6 inches. 13.2 by 6 inches. Do the drawing to help you out. So now I have this drawing. This is my 13.2, so now I know that that's going to be 22. And I go ahead and I do this again. So I got my inches over feet, 3 over 5, because that's the ratio, 3 inches for every 5 feet. And 3 inches is 6, but I'm still trying to find this. Okay, I'm trying to find this length over here. But this one's pretty easy. 3 times what number gives me 6? Well, that would be 2. So I multiply this by 2, and so that gives me 10. So the drawing then is going to be 10. But I'm not done yet because it tells me I have to find the area of the actual studio. So the area, and this is a rectangle, so it's length times width. So now it's going to be 22 times 10. Of course, that's going to equal 220 feet squared. Because this is 22 feet, and that's feet. Okay, so this is feet squared. Okay, so we call that squared. So in this last piece here, we're looking at a scale drawing of a meeting hall is drawn on a centimeter grid paper as shown. The scale is 1 centimeter is equal to 3 meters. So what they're saying is that that's 1, that's 2, 3, 4, 5, 6, 7, 8. So that's 8 centimeters. I'm going to put that on the inside. But for every centimeter, it's 3 meters. So if I just count this and skip count, 3, 6, 9, 12, 15, 18, 21, 24. So that's 24 meters. And then I can do the same thing on this side. Okay, so it's 1, 2, 3, 4, 5, 6. So I count 6 centimeters and I skip count. 3, 6, 9, 12, 15, 18. So that's 18 meters is what the actual length would be. So suppose you redraw the rectangle on a centimeter grid paper using a scale of 1 centimeter is equal to 6 meters. In the new scale, 1 centimeter represents more than or less than 1 centimeter of the old. So you tell me which one that is. The measurement of each side of the new drawing will be twice or half as long as the measurement of the original. You tell me what that is. Draw the rectangle for the new scale of 1 centimeter is equal to 6 meters. What they don't tell you is that you're going to keep the original outside dimensions. So you're going to keep 24 meters. So what we're going to do is we're going to pick a point right there. And I'm going to count. I need 24 meters. So if again, skip count. So 6, 12, 18, 24. So that's going to be 4 centimeters, right? 6, 12, 18, 24. And now I have to go 18 meters. So I'm going to, so that's my 24. Let me write that up there. Now, again, skip count. 6, 12, 18. So that's going to be 3. So then I just finished drawing that off. 18 meters. Okay. So this is now going to be 1, 2, 3, 4. And this is 1, 2, 3. So that's the new rectangle. So now if you go back and take a look in the new scale, 1 centimeter represents more because it's 6. The measurement of each side of the new drawing will be half. So if you take a look here, it's going to be half. 8 is half, or 4 is half of 8. 3 is half of 6. So go ahead and work on doing the reflect here. And you have the guided practice that you could work on. And we can answer any questions that you have in class. Hope this helps you out. Have a good day.